Hi, in this video, we're going to go through some summary statistics using R. We're going to experiment with some data from the World Bank. I'm going to be running some summary statistics like finding the mean, finding the the median, etc. So let's get started. So the main topics: calculating basic summary statistics, and we'll be creating some basic scatter plots. I'll also do a box plot as well, broken down by the different regions. So this should get you started. If you want to know a little bit more about more advanced plotting, make sure to check out the set of videos on ggplot. I'm going to be just using the built-in base functions here for plotting. But there are many packages in R, most notably the ggplot2 package, which is probably the most widely used package in R to do your plotting, basic plots using a data set like this. Right, so let's get started. The first thing you should do is change the work directory or find some way, aside from clicking on this drop down, you should import the data into your workspace or your environment. I've already changed the directory, my work directory, to the place I want. I'm going to bring the data in, import the data in. That's the table I just showed you earlier. I'm going to call this object WB. I'm going to run the read.csv function. Okay, and the name of my file is worldbank.csv. So I'm going to run that in. Okay. And as I've shown in different videos, I'm going to use the head function here to look at the first 6 rows of this data frame. So this is a data frame. It'll come in as a data frame. And there are multiple columns here, multiple variables. But the main thing is like everything is distinct. Each row represents basically a country. And so each row represents a country. It tells you the code, the region, population, the over 65 proportion of population. So, what percentage of your population is over the age of 65? Under 15, what proportion of population under 15? Fertility rate, I believe this is the birth per woman. Life expectancy is the total life expectancy across all genders, everybody. Child mortality, I believe this is per 1,000 birth. Gross national income, that's the GNI. Literacy rate, mobile subscriptions, primary school enrollment rate based on female and male. So, so this is the data we're looking at. This is very, there's a lot of cool things there's a lot of cool data from World Bank. So if you're interested, I strongly encourage you to check it out. A lot of things you can do with the really the huge volume of data you can get from the World Bank. Okay, so let me start. Let's start simple here. Okay, let's say I want to experiment. I want to do an analysis, or I want to just take a closer look at a particular variable. Okay, the way we select a specific variable or column in a data frame in R is simply using the dollar symbol. I can do WB $. Okay, as soon as I do that in RStudio, it gives me options here. Okay. I'm going to select over 65. So if I run that line using pressing Control Enter, it shows you the values for these so there's 184 rows. So there's 184 values in this column. Okay. So it just tells you in order, the values of this column. So if I look at WB over 65 column, okay, I'm just reading off these values going down this column. Okay, that's what happens when I select that column. Okay, so let's say I want the average of that column, right? Then what do? I could just use the mean function, the built-in mean function. So mean parentheses, then put WB $ over 65. Okay. Now again, when I ran this line, this is just a vector of values, right? Vector of numeric values. So run mean of the vector of numeric values, I get the average across the entire column or the entire vector. Okay. So this is the average. So this is the proportion of the population that's over 65 across these 184 countries. Okay. What if I want to know the standard deviation? Right? So this gives me standard deviation will tell me the spread of that number or that variable. So I'm going to run the SD function, WB $ over 65. It gives you 6.32, right? So this gives you some of the spread. If this number is really high, that means there's a lot of variability in this number and it's really widely spread out. If the number is very small, that means this is a small variability and really the spread of this value is very narrow, okay? Let's look at some other things. So we could also use the summary function, okay, W $ over 65, and it tells you the minimum, the first quartile value, median, the mean, third quartile, and maximum value for this particular variable, okay? So the summary function is also very useful, okay? What some other useful things I can answer, that I can answer some of the questions I might have is like, I want to know, which country has the smallest proportion of population over 65, or which country corresponds to the smallest value of this variable over 65, for example, right? So what can we do to find that out? There's a built-in which.min function, okay? So I can run which.min and then put in the column here, WB $ over 65. This tells me then the location of where the minimum value occurs. Not the actual minimum value, but the location, okay? So 4 means the fourth value in the vector has a minimum value, which also means the fourth row or the fourth observation in my data frame has the smallest value, okay? So then once we know this, we could actually output which country it is directly, right? So I can do WD $country. Oops. Let's do country. Okay. I'm gonna put a bracket, okay, to set a condition, which.min WB $ over 65. Okay. So remember, this was 4, right? This outputs 4. So the fourth country listed in our data frame, or the fourth row, okay, United Arab Emirates, has the smallest proportion of population that's over 65. I believe I pulled this data for 2018, so it's fairly recent. So the UAE has the smallest population that's that's over 65. So it's a very young country in a sense, right? Or there aren't as many older people in this country. On the flip side, you might have a question. You might wonder, I wonder which country has the most over 65 population. Okay, so the counterpart to which.min is the which.max function. So which.max WD over 65, and the index we get is 83, or this is the location in which the maximum value occurs for this W $ over 65 variable. Okay, so it's the 83rd row. Okay, so we can do WD $ country. I can kind of guess which country this is already. It's a country in Asia, I think, an island nation. Okay, that's the country I was thinking. Japan. Japan has the highest proportion of population over 65. Okay, you might wonder then. I wonder what that value actually is, right? Okay, Japan's the highest. What's the value? Okay, I could do that in multiple ways. I can look at the summary of WB $ over 65. Okay, that's one way, but really it tells you 27. But really, what you really want to do here then is WB bracket which.max. I'll show you 2 ways, right? 65. Put a comma now because we're referencing the entire row. I'm sorry, I'm not specifying a column here with the $. I'm specifying the entire data frame. So I got to give it a row index here. This is a row index, comma, no value for the column index means I return every column, okay, for that row. So then I get Japan, and I can see here over 65 is 27.57. Okay. Another way is just doing WB $ over 65, and then which.max WB over 65. Okay, 27.576. Okay, so this is a country with the highest proportion of the population over 65. So roughly more than 1/4 of the country is over 65, right? It's a very gray population. Okay, FYI, every country is getting older, right? We live longer, so we tend to. Most of the industrialized countries is aging very quickly. So this is not. It's very common. Okay. Okay, so let's do, so this just gives you, basic functions here, the mean, standard deviation, summary, which.min, which.max. I think these are simple enough for you to get started. Let's do a simple scatter plot here. Let's plot the fertility rate and the gross national income, or GNI, which is analogous to the GDP, okay? But what we're looking at is the gross national income per capita, okay? So this gives us a rough idea, a good measure of the wealth of that nation, okay? So I'm gonna do plot. This is, again, the built-in function. Again, there are many different ways to plot it. Really, the most powerful, I think the most useful package is ggplot2, which you can look at some of my other videos to help you, plot different things using that package, okay? So let's put WB, let's put the gross national income per capita on the x-axis, and then let's put the fertility rate on the y-axis, okay? So I'm gonna run plot here. Let's zoom into this. I'm gonna zoom in right here. And let me make sure this is sharing correctly. Oh, this didn't pop up. So here's the plot, okay? So I have GNI, gross national income. Remember, this is per capita, per person, right? On the x-axis, and then fertility rate on the y-axis. So what is the overall relationship? It's there's an inverse relationship, right? So as the gross national income per capita increases, the fertility rate drops, okay? Again, there are many reasons why this happens, okay? But wealthier nations tend to have lower birth rates, okay? That's, if you look at Europe, you look at, wealthier countries in Asia, etc., their birth rate starts declining very rapidly as a country gets wealthier, right? So, but there are outliers, right? There's one outlier here. We're kind of curious to see which country this is, okay? So, but this gives you a rough idea of the inverse relationship between fertility rate and GNI, okay? So this is a simple scatter plot, okay? So let me get out of there. Let me go back to RStudio. Let's look at the whole picture here. Okay, so that gave me a scatter plot, right? But let's say I'm going to investigate some of those outliers, okay? Just look at the outliers, okay? So I'm going to call this outlier countries. Okay, I'm going to now subset, okay, which means I'm going to take that the main data frame WB. I'm only going to select certain rows or observations that satisfy a certain set of conditions. Okay, and that's where the subset function comes in. There is another way of doing this, but I'm going to use a subset function here just to demonstrate. WB, comma, and then I want the GNI, the gross national income per capita here, to be greater than 10,000. Okay. So we're looking at a country above 10,000 over here, right, in this part, okay? At the same time, on the fertility rate, okay, so and the fertility rate to be greater than or equal to 2.5, okay? So the natural replacement rate for fertility rate is 2.1, okay? So if your country has to refer to a 2.1, then your population should relatively stay flat. Beyond that, then your population is increasing. Below that, your population is declining. That's the rough estimate, right? So I'm gonna run this. Let's see what we get here. So let's look at what outlier countries look like, okay? There are only two countries in this data frame. It's Israel and Oman, okay? So I'm gonna, let's do the strpn function so you can look at it more in detail here. Okay, all the variables, there's only two countries, two observations for 10 variables, Israel and Oman. Israel has a population of 8.8 million. Oman has a population of 4.8 million. Their incomes, to gross national income, 40,000 per capita, 14,000 per capita respectively. And it looks like the fertility rate, for 3 points, right? So this value right here, the outlier that we saw earlier, that's Israel, right? High fertility rate, as well as a high gross national income. Okay, all right, let's do another couple of more examples here. Let's look at the life expectancy variable. Okay, so life expectancy, what is the expected life if you were to live in that country? What is the average life that you expect to live before you die, right? So let's look at the histogram of the life expectancy variable. Okay. So right here, see some countries. So this is skewed in a way where there are a lot more countries that have much higher life expectancies, okay, which is good, right? I think, the longer, healthier you live longer, the better it is. I think more and more countries are, people are living a lot longer, healthier, which is good. Okay. Let's actually though. I mean, I think this is one way to look at it, but now let's break it down by the region. Okay. Let me pause here really quick. Remember, there's this variable called region. Okay. Now, rather than using head WB, let me do the table function W and then region. Okay. Remember the table function for some other variables. It counts up the number of observations for that particular column, right? So there are 4 columns in this data frame where there's no value for the region. There's 2 countries in North America. My guess is that's the US and Canada. And then there's 26 countries in Asia. There's 46 countries in sub-Saharan Africa, 20 countries in East and North Africa. Right, so there's this data frame, FYI, also this data from World Bank also has not just nations, but they have like different very specific zones and specific areas as well. So you might have more countries listed. Okay. All right. So we have these main regions. Now let's try to break this down. Let's try to break down the data based on the region and not just looking at the licensee for the entire world together or all the countries in this data frame together, because that might kind of present the wrong idea here, right? Maybe certain areas have a much better, higher life density. Some areas might have a very much lower life density, etc. Let's at least break it down by the region to have a better idea. So I'm going to use a box plot function here. Again, this is built in. This is just a base function, right? So I'm going to use WB $ life density. Okay, so I can create a box plot of just this variable. And if you do that, basically what you're doing is running the summary function and showing it in a box plot, right? So this is the median in the middle here. That's the first quartile, third quartile, right? Okay, and the min and the max, right? So it's the I'm sorry, not the min and max. They'll show you some outlier too. I believe this should be the inner quartile range. So let's look at this broken down by the region. Okay, to do that, all you have to do is add a tilde and then give some variable that you can use to break this up. Okay, and we have this region variable, right? This is it's not a numeric variable, right? It's just, R will basically treat this as a set of factors, the set of different factor levels. Okay, so if I run this, now it's broken up. Let me zoom in here so you can see the entire x-axis here. And let me share that plot there. So now you have, all the different regions. Let me, I have to change the resolution a little bit so you can see the x-axis here. So some areas have a much higher life density versus other areas, right? So North America, for example, has a very high one. Some other places like East Asia and Pacific, I mean, it's got a wide range here, but on the median is actually much lower, right, than a place like North America. South Asia, slower, a narrower range, and overall a lower median. Now, sub-Saharan Africa has a very low value. Okay, and this is probably this is Middle East. Oh, Middle East and North Africa has a very relatively higher life density. Okay. The point here is now we've broken up this data by region and you have a lot better understanding of what's going on. Okay. All right. So let me pause it there. Okay, let me go back to our studio. Okay. So yeah, hopefully this gets you started. This helps you out understanding how to import the data in. And then we ran some basic functions, very basic summary statistics on data from the World Bank. Okay. Hopefully this is helpful. Make sure you check out some of the other videos if you have a question on how to run some of the other functions in R that helps you do your analysis in a project wherever you're working on. Okay, so best of luck, and thanks for watching. Take care. Bye.